Hello everyone, welcome to Concepts in Chemistry YouTube channel. So today in this video we will be discussing some more questions from BARC second phase exam. So we already discussed 20 questions from BARC second phase exam in our first video, and from BARC first phase exam. So we have discussed more than 50 questions. So let's discuss some questions from BARC second phase exam. So before starting the question discussion, so I want to thanks Akila and Amit Kumar. So they shared a lot of questions in the comment box. So from those questions, I picked up some, and yeah, we'll be discussing some of those questions in this video. So thanks again, Akila and Amit, to share uh, questions in the comment box. So let's start. So yeah, before starting discussing of new questions, so I want to inform some extra information about. So I want to give some extra information about two uh, questions which I already discussed in first part of second phase exam. So regarding these questions, and on questions is regarding that liquid junction potential. So yeah, in the first video we will discuss these reactions, and we discussed there, and we finalized the answer of the reactions is. So हम लोगों ने डिस्कस किया था ये वाला क्वेश्चन का आंसर, जो फर्स्ट वीडियो में हम लोग को फाइनलाइज किया था इस क्वेश्चन का आंसर ये होगा. बट ड्यूरिंग दैट टाइम मीन्स व्हेन वी आर डिस्कसिंग दिस क्वेश्चंस, सो मुझे ऑप्शन के बारे में कुछ पता नहीं था, जस्ट क्वेश्चन पता था. सो सो थ्रू मैकेनिज्म हम लोग डिस्कस किए थे, इसका आंसर ये होगा. बट या मैंने कमेंट बॉक्स में देखा कुछ लोगों ने कमेंट किया, जो एंड they also said that there is some particular options so regarding that cyclization. So yes, in these questions, so up to this means which reactions first, which reaction will occur. This is 100% confirmed. There's no elimination of Br, no substitution of Br first which reaction will occur. Up to this it will find. So from this molecule, if we have to see the options, because there are in this molecule there are three possibility. This is the molecule, this is a allylic, this is allylic positions, and bromine is there. So these positions is prone to a substitutions, that is SN2 substitution, since it is a allylic positions, and allylic position is good for substitution reactions, nucleophilic substitution reactions. So one possibility is this: there is base means sodium ethoxide, so this can attack these positions to substitute Br, so we will get this kind of product. But I don't know, मुझे पता नहीं था ये वाला ऑप्शन उसमें था या नहीं, ये वाला ऑप्शन था या नहीं. अगर ये वाला ऑप्शन भी था, और see this compound after Wittig reactions, since there is base, so in presence of base both the OH group will deprotonate. Now see, in this case intermolecular nucleophilic substitution occur, because external nucleophile OH minus attack these allylic positions, Now see, this is internal nucleophile, so this can be attack this position, allylic positions, or these positions. So if this internal nucleophile close to the close to this allylic positions, if it will attack these positions, then we will get this kind of product with a strain 4-member ring. If this O minus will attack directly the uh, positions where bromine attached, then we will get a stable molecule like 2 6-member ring. So three possible product, 1 2 3 in the options. If they are, if ऑप्शन में तीनों ऑप्शन था, अगर चार ऑप्शन में से तीनों ऑप्शन है, so the major product will be this, because we all know intramolecular reactions is faster than intermolecular reaction. So in this case, intramolecularly substitution occur. So here also two possibilities. One is this compound, one is this compound for product formations. Since one 4-member ring is there, so it is strain. This is 2 6-member ring stable compound. If in the options there are these three product, but still the most stable of this is just intermolecular nucleophilic substitution, so less feasible than this intramolecular substitutions. Among this intramolecular substitution, there are possibility of two product formations. One is this, another is this. So this product will be formed in major amount. So अगर ऑप्शन में बाकी और भी कोई ऑप्शन होगा, अगर ऑप्शन में ये और बाकी दो अलग ऑप्शन है, तो ऑब्वियसली आंसर ये सही होगा. अगर ऑप्शन में ये भी है, ये वाला, इन दोनों में से दो ही है और बाकी एक ऑप्शन है, तब भी आंसर यही होगा, बिकॉज this product obtained by intermolecular substitution. These two are intramolecular. Among these two, this is stable, this is less stable. So this will be the major product. अगर ऑप्शन में ये था तो ऑप्शन सही आंसर ये होगा. ऑप्शन में ये नहीं था, among the 4 options, if there is 1 and 2, अगर ये वाला ऑप्शन था, ये वाला ऑप्शन भी था, तब भी ये वाला ही सही आंसर होगा, because this product will form by via intermolecular nucleophilic substitutions. So this O minus cannot be attacked this position because distance is so far. So only this O minus adjacent to these positions will attack and form this kind of product via intramolecular substitution. So ये क्वेश्चन हम लोगों ने पहले डिस्कस किया था, हम लोगों ने आंसर देखे थे, उसका आंसर ये होगा, बट तब ऑप्शन पता नहीं था. बस मैंने कमेंट बॉक्स में देखा, कुछ लोग ये ऐसा कुछ ऑप्शन था, उन लोगों ने बताया. सो इंटरमोलिकुलर सब्स्टिट्यूशन प्रेफर होगा इसमें. इन दोनों प्रोडक्ट में अगर ये दो ही ऑप्शन है तो ये वाला आंसर सही होगा. अगर ये तीनों ऑप्शन में है तो तब भी ये वाला आंसर सही होगा. ये नहीं है, अगर ऑप्शन में ये है और ये वाला है तो आंसर ये वाला ही होगा. सो ये एक क्वेश्चन का कुछ एक्स्ट्रा इंफॉर्मेशन डिस्कस करना था. नेक्स्ट और एक क्वेश्चन. सो ऑल्सो दिस क्वेश्चंस वी हैव डिस्कस्ड इन आवर फर्स्ट वीडियो. सो पहले इस क्वेश्चन के बारे में उतना कुछ डिटेल पता नहीं था. सो बस मुझे पता चला क्वेश्चन में ऐसा कुछ था, लिक्विड जंक्शन पोटेंशियल. मैंने फर्स्ट जो मुझे पता चला इस टाइप का क्वेश्चन के बारे में. सो MCl एक सॉल्ट, सो व्हिच सॉल्ट विल effective to eliminate the liquid junction potential. So which salt we can use as a salt bridge to eliminate the liquid junction potential. So that case we have discussed there. We all know that such kind of salt or electrolyte, this inert electrolyte we can say, whose cationic and anionic mobilities are close to each other, means same mobilities, then we can use that electrolyte as inert electrolyte in salt bridge to eliminate the liquid junction potential. So but recently अकीला ने कमेंट किया, जो एक्चुअल क्वेश्चन था वो क्वेश्चन था, for which electrolyte liquid junction potential will be higher. This MCl chloride is same for every chloride, but every electrolyte we have to find the M, means cation. For which cation the liquid junction potential will be higher? So that questions, these two questions, first we assume the questions which electrolyte we can use as an electrolyte in solid breeze to eliminate the liquid junction potential. Now the question is which salt we can use, which salt will give higher liquid junction potential. So these questions answer completely different होगा opposite होगा, because question अगर ये है तो जो आंसर होगा उसके जस्ट ऑपोजिट होगा अगर क्वेश्चन पूछा गया ऐसा लिक्विड जंक्शन पोटेंशियल किस केस में हायर होगा. सो एक्चुअली कमेंट बॉक्स में अकेला सो कमेंट किए थे जो इसका जो एक्चुअल क्वेश्चन था वो कौन सा केस में, कौन सा इलेक्ट्रोलाइट केस में लिक्विड जंक्शन पोटेंशियल हायर होगा. सो you all know some basic concepts regarding liquid junction potential. So uh, so just this is some uh, to establish these equations of liquid junction potential we have to see lots of calculations, lots of derivation. So if we consider this kind of cell, so liquid junction potential so liquid junction potential generates when two different electrolyte or two half cell of same electrolyte with different concentration. See, here we use same electrolyte HCl, but as different concentration are come close to each other, then a junction created, and so when this electrolyte come close to each other, then there is migration of ions across these junctions. Across these junctions, so due to this migrations of ions, so there is generations of a potential. There is generation of the potential, and that is called as liquid junction potential. So this will only take place when we consider electrolytic cell with transport. So there are two types of cell with transport, cell without transport. So there is a detailed discussions of electrochemistry, electrolytic cell. So just focus on this expression. So EJ means potential of liquid junction potential. Potential at liquid junction. So liquid junction potential. So from uh, this A plus is the mean ionic activity. So if we consider this kind of cell, electrolyte cell with with transport, if A1 activity of A1 activity of this electrolyte HCl and activity of this electrolyte HCl. So if A1 greater than A2, then we can write the uh, potential expressions at liquid junction. So it will like as T m plus transport number of cation minus transport number of anion. So in this case Cl minus. In normally we used to normally मैक्सिमम केस में हम लोग क्लोराइड सॉल्ट यूज करते हैं KCl, HCl, NaCl. इसलिए मैंने यहाँ जनरलाइज कर दिया Cl लिख के. इसमें हम एनायन भी लिख सकते हैं. सो T प्लस माइनस T Cl माइनस RT by NF ln A plus minus 1, A plus minus 2 means activity of mean ionic activity of 1, mean ionic activity of 2. So from this case, thus the liquid junction potential depends on two functions. One is difference in transport number, or we can say mobility. Transport number, transport number and mobility same चीज नहीं है, but we can compare this uh, this phenomena. Same transport number is comparable with mobility of ions. Transport number is comparable with mobility of ions. So difference in transport number or mobility of the two ions means cation and anions. Activity of the ions in the two solutions. See here, activity means the concentrations of the two ions means two electrolyte in the solution. So from this expression we can say when T plus equal to T minus means mobilities or transport number. I am again telling you that transport number and mobility are different, but according to their characteristics, we can say these two phenomena, transport number and mobility, quite comparable. So if we assume mobility of ions or transport number of ions, we will obtain same results. So if transport number of cation and anion are similar, then Ej becomes 0. From this C, Ej becomes 0. That's why we have discussed there, when the mobility of cations and mobility of anions, or we can say transport number, are quite similar, then that liquid junction potential will be 0. That's why we use KCl, K plus and Cl minus have same mobilities to eliminate the potential at junction. So to eliminate the liquid junction potential. If T plus means mobilities of cation is greater than mobilities of anions or transport number. So I am saying here mobilities. So then Ej positive, Ej become positive means higher. If T plus less than T minus, then Ej become negative. So transport number or mobilities, transport number, or you can say indirectly mobilities of cation, that is M plus, become more, then the more will be the liquid junction potential. From these expressions, more will be the liquid junction potential. See in this case, so these are some datas. So I put here. So see electrolyte HCl, lithium chloride, sodium chloride, KCl. See the transport number. Transport number value of cation 0.83 means H plus. Transport number of H plus is 0.83. Highest lithium 0.33, sodium 0.39, potassium 0.49. Just see the value and see the mobilities of that H plus. Highest 36, lithium 4.01, sodium 5.1, increasing. Lithium to sodium to potassium increasing. See, increasing. The value are different, but there we can compare transport number with mobilities of ions. So these are, and this see Cl minus mobility is 7.9 on, K plus around 7.62. So see for potassium and Cl minus, the mobilities of an anion and cation are quite similar. That's why we use KCl or NH4NO3 as inert electrolyte in solubles to eliminate the liquid junction potential. Now see, for H plus, the mobilities is highest. See here, the transport number of H plus is 0.83. So this is cationic transport number 0.83. So for HCl, for HCl, see from the data, for HCl, this value is highest. T plus minus TCl minus. TCl minus is constant for every M, sodium, lithium, potassium. For M plus equal to H plus, this value will be highest, means Ej will be highest. So liquid junction potential will be highest for ACl. And which for which case it is lowest? See, for lithium. For lithium, the transport number is very low. For lithium, the transport number is very low, and for lithium case, this value T M plus minus TCl minus become lowest. So liquid junction potential will lowest for lithium. So for which case, if we use HCl as electrolyte, then the liquid junction potential will be highest. You can see the data. If we put 0.83 in these equations, then TCl minus have some transport number. This value will be highest for HCl. For lithium, sodium, potassium, see the transport number increases. See size increases according to transport number increases. So this is somewhat contradictory result. See in case of mobility also. So For this, we have to consider their effective size in uh, their effective size in hydrated versions. Means since they are unipositive cation, all so lithium plus, sodium plus, K plus. So since lithium plus size is low but charge is same for three cation, but size of lithium plus is small, so the hydration will be, means charge density will be high for lithium plus, so hydration will be more. So the hydrated size, means for lithium case the hydrated size will be more than sodium plus, and the uh, hydrated cationic size of sodium plus will be more than potassium plus. So the effective size after hydration will be lithium plus greater than, so lithium plus is more, size of lithium plus hydrated cationic size of lithium plus will be more than sodium plus, and that will be more than potassium plus. That's why the effective size is, in these three cases if we consider, the effective size is more for lithium plus, and this is more, uh, lithium plus has more high effective size, and potassium plus is of smallest size. So that's why the transport number of or mobilities will increases from lithium to potassium. But in case of H plus C, in case of H plus, there is a large deviations, 36.3 mobilities from 4.2, 4.90 to 8.23. So in this HCl, for H plus ion, हम लोगों को ये नॉर्मली ये कैटायोनिक साइज के थ्रू ये डिस्कस नहीं कर पाएंगे। इसके लिए हम लोगों को कंसीडर करना होगा वो हाइड्रोजन बॉन्ड, हाइड्रोजन बॉन्ड के थ्रू H प्लस ट्रांसपोर्ट होता है। वो एक अलग सा मैकेनिज्म होता है, उसको बोलता है ग्रोथस मैकेनिज्म। सो ग्रोथस मैकेनिज्म के थ्रू हम लोगों को देखने को मिलता है वो वाला H प्लस कैसे ट्रांसपोर्ट होता है via हाइड्रोजन बॉन्ड, via चेंजिंग ऑफ हाइड्रोजन बॉन्ड, via फॉर्मिंग ऑफ हाइड्रोजन बॉन्ड with water, by forming of hydrogen with water. That's why it moves faster, its transport number is so high, its mobility is so high uh, than this lithium, sodium and potassium. And we have to consider the effective size of the lithium, sodium and potassium. That's why from lithium to potassium the effective size will decreases, that's why the mobilities will increases. So these two questions के बारे में कुछ एक्स्ट्रा इंफॉर्मेशन देना था। अगर so the correct answer will be HCl for the questions for which case the liquid junction potential will be higher, and for which salt we will use as a inner electrolyte in salt base to eliminate liquid junction potential, that will be K plus and Cl minus, means KCl. For that case EJP close to zero, means liquid junction potential close to zero. The reason is that their mobilities are same. So now discuss few more questions. So from quantum chemistry एक ऑपरेटर और आइगन फंक्शन रिलेटेड क्वेश्चन था। उसमें से क्वेश्चन पूछा गया था एक फंक्शन, so they were given a functions and we have to find, I think ऑप्शन में 4 ऑप्शन था, we have to find correct options of the operator which will be the, so which will be the eigen operator of that function. So 4 ऑपरेटर दिया गया था ऑप्शन में एक फंक्शन। सो क्वेश्चन था फॉर व्हिच ऑपरेटर दिस फंक्शन विल बी अ आइगन फंक्शन, ऐसा कुछ क्वेश्चन था। सो नॉर्मली फ्रॉम द properties of eigenfunctions, so if is any functions, arbitrary functions, if a is a eigenfunctions of operator a, then this equation should be satisfied for every case. Means if we operate by operator A in these functions, if we operate this function by operator A, then we will get functions along with some constant. A is a constant, real constant. So A is a real constant. If a function is given, if we operate by a operator in that functions, if we operate the functions by a operator A cap, then if we will get the function, the original functions along with a constant, it is a real constant. So is the value of A should be 1, -1, 2, -2, any values, that is real constant. So if we obtain the functions back along with some constant value, then that is called eigen functions. F is called eigen functions and A is called eigen value. So in the questions जो कमेंट बॉक्स में शेयर किया, so according to that, so the function was like that, 4x cube minus 3x. 4x cube minus 3x is the functions, and the 3 operator, I think of चार ऑपरेटर दिया गया था ऑप्शन में. सो बस इसमें 3 ऑप्शन पता चला, बाकी एक ऑप्शन जो नहीं पता चला वही करेक्ट आंसर है. बट सी द रूल्स इज दैट यू हैव टू ऑपरेट every operator to these functions. So you have to operate this function by the given operator. So d2 dx2, if we operate d2 dx2 with f means these functions, then see d2 x2 means d dx, we can separately like write like d dx into d dx. First we operate with d dx as to these functions, then अगर हम लोगों ने ये वाला ऑपरेट कर लिया डी डी एक्स दैट फंक्शन, वी विल गेट दिस 12x square minus 3. Again, 1 ddx is outside, so we have to again operate. This means differentiate with ddx. We will get 24x. X square d2x2. So x square, this is a multiplicative operator. So that's you have to multiply by this. So d2x2 you can write multiplying by this x2, 4x5 minus 3x cube. If we differentiate this, we will get 80x cube minus 8x. So from first second, if we take any common value, then we will not get the original functions back. So if we see option operator 3, then after calculation, this is just simple calculations regarding operator algebra, regarding just differentiations, multiplications of simple terms and differentiations. So this option, this operator 3, if we operate with to these functions, then we will also get some kind of value. But for this operator, this f functions, if f is eigenfunctions of any operator of these three, one operator is missing, then after operating, after all these calculations, finally we should obtain that original functions along with some constant. But हम लोगों ने देखा ये तीनों जो ऑपरेटर अभी तक पता चला, जो क्वेश्चन में एक शायद फोर्थ ऑपरेटर था वो नहीं पता चला. सो ये तीनों ऑपरेटर में ऑपरेट करने के बाद हम लोगों को ये वाला फंक्शंस वापस नहीं मिला. along with some constant it's okay, but ये वाला फंक्शंस नहीं मिला ये तीनों ऑपरेटर से. सो जो फोर्थ ऑपरेटर था ऑप्शन वही होगा. जो अगर किसी को फोर्थ ऑपरेटर का एक्सप्रेशन याद है तो आप लोग वो वाला ऑपरेटर लाइक दैट ऑपरेट करके ये वाला फंक्शन के ऊपर ऑपरेट करके देख लीजिएगा. ये फंक्शन भी वापस आ जाएगा अलॉन्ग विद सम कांस्टेंट, दैट इज माइनस और प्लस एनी कांस्टेंट वो हो जाएगा. सो out of these three operator, no one is the out of these three operators, we can say that this functions is not a eigenfunction of these three operator. So जो ऑपरेटर अभी तक पता नहीं चला वो फोर्थ और पता नहीं कौन सा ऑप्शन में था, वही होगा उसका ऑपरेटर या आइगन फंक्शन होगा उस ऑपरेटर का. इफ वी ऑपरेट by this operator to these functions, then we will get this function back and along with some constant value. So ये था एक ऑपरेटर रिलेटेड क्वेश्चंस. सो लेट्स सी नेक्स्ट क्वेश्चन। सो एक क्वेश्चन था जो कोबाल्ट एक्सा अमोनियम कॉम्प्लेक्स था, कोबाल्ट 2 प्लस, और एक कोबाल्ट टेट्राक्लोराइड का कॉम्प्लेक्स था, both case cobalt 2 plus, so one is octahedral, another is tetrahedral. So you have to find the uh, spectroscopic ground state term symbol. So question में था spectroscopic ground state term symbol. So by this way we can find the molecular term symbol. So ऑप्शन है तो आप लोगों को पता चलेगा, बिकॉज अगर ऑप्शन में ऐसा कुछ है A2G T2G और 4F समथिंग मीन्स तो पता चलेगा, बट मैक्सिमम केस में बहुत सारे स्टूडेंट गलती करते हैं ये वाला केस में। spectroscopic, they just after seeing that ground state term means they normally used to think that this kind of, if there is uh, you have to fill a blank space, or yeah, blank space, then मैक्सिमम केस में ये लोग गलती करेंगे ये वाला क्वेश्चन में। जस्ट आफ्टर सीइंग द ग्राउंड स्टेट टर्म दे विल थिंक दैट molecular ground state term. So they will put this value. But in this case, they mention specifically that is spectroscopic ground state term for both case. So by these calculations for D7 cobalt, that is high spin. For this case also high spin. This case also high spin. Tetrahedral high spin and cobalt 2 plus NH3 also high spin. So for D7 high spin, if we calculate the L value, total angular momentum, then it will become 3, and it corresponds to the F. If atomic state, that is term F term, and S, that is spin angular momentum, become 3 by 2. So 2s plus 1 become 4. Now J value become 9 by 2. J value L plus S means this is more than half filled, so L plus S 9 by 2. Now the molecular ground state term for this cobalt 2 plus high spin, molecular ground state term for cobalt 2 plus high spin become 4F 9 by 2. So we have to find the spectroscopic ground state term symbol for both case, that is D2 octahedral, D2 tetrahedral. For this we have to draw the organelle diagram. So see, this is the organelle diagram of D7 octahedral high spins, and in this side I draw D7 tetrahedral. So 4F is the ground state term. In this case, that is D3, D7, D2 and D8. Particularly for this 4 D configuration, we have to consider the upper term, that is P term. So if we draw this organelle diagram, then we can see that for D7 octahedral, the spectroscopic ground state term is 4T on GF. So see here 4 spectral term is there. 3 are from F and 1 is from T. T1G from 1 T1G from P term. That is 4 T1G is from P term and 4 T1G this is from F term. So for D7 octahedral, the ground spectroscopic ground state term is 4 T on G F. So F should be mentioned there because in this case 4 T1G term is 2. One is comes from P term, one is comes from F term. So just if we draw like that, that's opposite like that. In this case, some intention will happen, so it will tilt it like that. You all know this kind of drawing organelle diagram. So just for tetrahedral D7, just opposite will be the result. For ground state spectroscopic term, it will be 4A2. So I will not wrote here A2G because tetrahedral no symmetry is there. That's why only 4A2. Also that is from F. Also 4A2 is only for F, only one term, that is only from F term. So the spectroscopic ground state term symbol for D7 octahedral is 4T1G from F, and the spectroscopic ground state term symbol for D7 tetrahedral is from 4A2, just 4A2. I draw 2 times, same draw. In this case, D7 octahedral, I draw in this case D7 tetrahedral. In this just opposite, just left side D7 tetrahedral, and just left side I draw this one octahedral. This and these are same, and these are same. So by drawing the organelle diagram, you have to find the ground state spectroscopic term. If there is any spectroscopic term mentioned, then we have to draw the organelle diagram, and we have to find the ground state term or the highest energy state term, the spectroscopic transitions. So in this case, for this one octahedral, the 4T on G term is ground state term, ground state spectroscopic term. For D7 tetrahedral, 4A2, because tetrahedral no symmetry is there, we cannot write G term, only 4A2. No G or U term will be there. So 4T on GF for D7 octahedral, 4A2 for D7 tetrahedral. So let's see the next questions. One question था cisplatin का point group. So see, this is cisplatin. So the point group of cisplatin is C2B. This is molecular plane. This is sigma v dash, and in this place C2 is there. If we rotate 120 degree, this NC will become that, this Cl will that. So on C2 to C2b E is present, means this point group is C2b. If upcoming any exam पूछ सकते हैं, they can ask with transplatin. So see, in this transplatin the point group is D2As. That's uh, that's for extra information. So cisplatin C2B, transplatin the point group is D2H. तो ये क्वेश्चन के बारे में कुछ डाउट है, बस ये क्वेश्चंस मैंने सोचा था ये डिस्कस नहीं करेंगे, बट जस्ट आई गॉट सम वैल्यूज. स्टैंडर्ड एंथैल्पी ऑफ फॉर्मेशंस. सो स्टैंडर्ड एंथैल्पी ऑफ फॉर्मेशंस पूछा गया था कौन सा केस में जीरो होगा. सो क्वेश्चन में H2O, I don't know there is any mentioning of gaseous species or liquid species like that, but जो अभी तक पता चला, जो कमेंट बॉक्स में शेयर करा गया, उसमें से पता चला H2O, मीथेन, Cl2 and bromine 2, चार species are given. These 4 species are given. We have to find for which case the standard enthalpy of formation will be 0. So by definitions, we all know that standard enthalpy of formation or standard heat of formations is the change of enthalpy when 1 mole of substance is formed from its constituents elements by considering a particular conditions that all the species should be their standard states. So all the species should be their standard states. So chlorine 2 gas, the standard enthalpy of formation is 0. Br2 gas, some value is there. For Br2 liquid, it is 0. See this value for H2O gas. This is the standard enthalpy of formations value. For H2O liquid, some value is there. For CH4 methane gas, also some value is there. Cl2 gas is 0. We all know that Cl2 standard state is gas, means Cl2 exists as a gas, but Br2 exists as liquid. So that's why standard state, considering the standard state of Br2, that formations heat of formation, standard heat of formation is 0, but Br2 in gas, some value is there. अगर क्वेश्चन में कुछ ऐसा ब्रिकेट में गैसियस और लिक्विड कुछ था, तो ऑप्शंस अगर गैसियस और लिक्विड था, ये वाला क्वेश्चन में थोड़ा अभी भी डाउट है, बट Cl2 गैस, the most probable answer the Cl2 gas 0. If there is no mentioning of gaseous or liquid species, but I don't know, but I just wanted to show some data, that's why I put this data in this question. So Cl2, formation of Cl2 gas, that is standard enthalpy of formation will be 0, but Br2 liquid case में 0 होता है, not gas. So standard enthalpy of formation Br2 liquid is equal to 0. If they consider all the gaseous species, if they considered, but if they did not mention any gas or liquid in bracket, but if they consider only gaseous species, formation of gaseous species, then answer will be Cl2, because for Cl2 gaseous the del A is F0 is 0. For Br2 gaseous it is not 0, some value is there. For Br2 liquid it is 0. So if they consider the uh, gaseous species, so in the standard enthalpy of formation, then the correct option will be Cl2. ऐसा भी हो सकता है कोई किसी भी क्वेश्चन में अगर लिक्विड गैस मेंशन नहीं किया तो Cl2 एंड ब्रोमीन 2 बोथ केस में 0 होगा बाय considering for Cl2 its gaseous species, Br2 its liquid species. और ये क्वेश्चंस का कुछ 100% आंसर मैं अभी कह नहीं पाऊंगा, बट अकॉर्डिंग टू मी, because water gaseous, CH4 gaseous, only Br2 liquid is equal to 0, Br2 gas some value. So I think they considered gaseous species in gaseous species. So that's why I think the answer will be Cl2. So if you guys, अगर आप लोगों को कुछ अच्छा information मिला regarding these questions, please comment in the comment box and try to write something details regarding this question. मुझे जो मिला information, just by that information I मैं सिर्फ इतना ही बोल सकता हूँ, ये क्वेश्चन का करेक्ट आंसर 95% 90% Cl2 ही होगा. Means if we consider the gaseous, all the gaseous species, del A is F0, then only Cl2 gas will be 0 and Br2 liquid will be 0. That's why I am telling you that Cl2 will be the answer. So if you will find some reasonable, more accurate explanation for these questions, please share. So that now come that question. So question is simple for methylamine primary, secondary amine and tertiary amine and aniline. These four species are given. Question ये था, which has the highest pKb value? So I write ammonia, methylamine, dimethylamine, trimethylamine, aniline. So this pKb value means more the pKb value, less will be the basic, less the pKb value, more will be the basic. Just like pKa, less pKa, more acidic, more pKa, more basic. So pKb value just see, for ammonia 4.75, for primary amine 3.34, secondary amine 3.27, tertiary 4.20, aniline 9.13. So क्वेश्चन में जो आंसर होगा वो जस्ट इफ वी सी द pKa वैल्यू, और अगर हम लोगों को pKa वैल्यू कोई भी अमीन का याद होता तो हम लोग सिर्फ pKa वैल्यू याद करके ये वाला क्वेश्चन का आंसर दे सकता है. मींस आंसर एनिलीन ही होगा, लेस बेसिक, मोर pKb value. So but if aniline क्वेश्चन में नहीं दिया हुआ होगा, अगर क्वेश्चन में ये तीनों एमीन प्राइमरी, सेकेंडरी, टर्शियरी एमीन क्वेश्चन में, किसी भी क्वेश्चन में अगर ऐसा कुछ प्राइमरी, टर्शियरी एंड सेकेंडरी एमीन दिया हुआ है, अगर उन लोगों ने पूछे, अगर उन लोग पूछता है ये बेसिसिटी ऑर्डर और ऑर्डर ऑफ pKb value, order of pKa value, then that will be the conceptual questions and tricky questions asked by them. Now let's see what why I am saying that is the tricky questions. If will they only uh, take this three amine and ask some questions like order of basicity, order of acidity. So just answer in this question will be aniline, the most pKb value, less basic. So now focus on this three amine, primary, secondary and tertiary amine. So basicity depends amine of any amine, basicity depends on the availability of lone pair electron on the nitrogen. You all know. So more the lone pair is available, more it will basic. Second point, basicity also depends on the plus I effect of the R group, means here methyl. So more the methyl group means more plus I effect. They will donate more electron density to the nitrogen. Lone pair electron or the electron density on the nitrogen will increase, then density will increase. This is first 2 point is basic point. Now, if there was given like aqueous solutions or no aqueous solutions, only gas phase kind of, means there is no solvent at all, then different case will be observed. So if we consider aqueous solutions, means in aqueous solutions this all the amines will be protonated and that nitrogen contain negative a positive charge. So this become protonated, these also become protonated and nitrogen contain a positive charge. Now see, this positive charge also, this positive charge on nitrogen also stabilized by electron donating group. See, R group, 3 electron donating group more stable. If we considering the protonated versions in aqueous medium of this amine, the protonated version of this amine, then we can see less R group means less electron donations, means less stability of that protonated versions. Only one R group plus the effect is lowest, less stability of that protonated versions. That is point 3. First, lone pair abilities of the uh, nitrogen atom plus I effect of the R group, which donate electron density and increases the electron density on nitrogen. That's why this leads to more uh, basic of this species. Second is the aqueous. If we consider aqueous solution of this bases, then there is protonations and nitrogen contain plus charge. If there is more R group, means more electron donating by plus I effect, stability is more. So in that case also, since this protonated version triethylamine is more, conjugate acid is more stable, that's why we can say the base is more basic. Since the conjugate acid means after protonation is more stable, we can say the basicity of this triethylamine is more high. But normally we observe different case. The basicity of triethylamines is less than dimethylamine. So among these 3 amines, primary, secondary and tertiary, the secondary amine is more basic. What is the reason? Now come to the point 4. There is another, if we are considering aqueous solutions, there is another uh, point, that is stabilization through solvent via hydrogen bond. Stabilization through solvent via hydrogen bonds. If there is water molecule, so it will form hydrogen bond with the water molecule. Now see, if in a species there is lots of hydrogens, means lot of hydrogen formations, means lots of stability. Less hydrogen means less of hydrogen bond formation, less stable. If we consider overall these 4 effects, 1, 2, 3, by 1 to point tertiary amine means, sorry, yeah, trimethylamine will be more basic because Plata effect is more. 3 R group is there. This is lowest. Only 1 R group is there. This is moderate, means second. 2 R group is there. By point 3, this will be more stable. The conjugate acid of this trimethylamine base is more stable because of the plus I effect of this 3-methyl group. So by also point 3, we can say this will be more basic. So from 1 to 3, point suggests that trimethylamine will be more basic and methylamine will be less basic. Okay, so only point 4 that suggests that the point says that in aqueous solution we have to consider the hydrogen bond formation, means the stabilization through solvent stabilizations. So see some, so this is primary, secondary, tertiary. So see, if secondary amine become protonated, there is two hydrogen in that protonated form. These two hydrogen will form hydrogen bond with water, solvent water. If this will protonate, only one hydrogen is there, only one hydrogen bond. If this will protonate, three hydrogen will be there, three hydrogen bond with three water molecule. In this case, only primary amine 1, 2, 3 point. These 3 point, these 3 points suggest that methylamine is less basic. Methylamine is less basic than other two, dimethyl and trimethyl. And these 3 points suggest that trimethylamine is more basic than other two. Now only point 4. It is also a strong point among these 4 point 1, 2, 3. We have to consider this not in a soft manner, but we have to consider this point in aqueous solutions. We have to consider. We cannot neglect this solvent effect. So by solvent effect, see here 3 hydrogen, lots of hydrogen bonding, greater stability. 2 hydrogen bonds, 2 R group. In this case, see 2 R group, also lots of electron donation, 2 hydrogen bond, lots of means moderate. Among these three, moderate hydrogen bonding, 2 hydrogen bonding. So this molecule will become more stable. This molecule will become more basic among of these two, because there is 2 R group, electron donations, conjugate acids, 2 hydrogen bond, more stable, means more basic. So even we are not considering the protonated versions, in unprotonated form there is also one hydrogen that will also form hydrogen bond, there is 2 hydrogen in unprotonated form, but in this case there is no hydrogen in unprotonated form. That's why still 3 R group is there, since there is no hydrogen in unprotonated form, or only one hydrogen in protonated form, that's form only one hydrogen bond with solvent, so it's become somewhat less stable. By hydrogen bond more stable, the but hydrogen bond is more in this case, but R group is 1. In this only this secondary amine, R group is 2 and 2 hydrogen bonds. So by overall considering the overall effect, this secondary amine will be more basic. And then see the pKa value also less for methylamine, and then this is more basic than trimethylamine. Since one R group is there, here 3 R group, which donate 3 R group donate 3 electron density more, but hydrogen bonds will be less. Only one hydrogen bond will be there in the protonated versions. Here 3 hydrogen bond, only one R group donate electron density, but in the solvent case 3 hydrogen bond will form, so it will become more stable conjugate acid. That's why the mother base become more basic than trimethylamine. So by considering the overall effect, dimethylamine, secondary amine, will be more basic in aqueous medium, and second is the primary amine, third is the tertiary amine. See the pKb value, it is more for primary amine. So in aqueous medium, more basic is secondary amine, then primary amine, then tertiary amine. If we consider no solvent, there is no solvent, or gas phase basicity means there is no solvent. No solvent means no water, polar protic solvent, no chance of hydrogen bond formation. Then we have to consider only the electron availability of electron density on the nitrogen atom. So in that case, electron density on the nitrogen atom will be more for this tertiary amine, and it will be more basic. If we consider gas phase, or there is no polar protic solvent, there is no chance of hydrogen bond formations, then the more basic is then this tertiary, then secondary, then primary. If we consider the aqueous solutions, there will be a different case, different situations. We have to consider all of the effect: hydrogen bond formation, electron donation by plus R effect, hydrogen bond formation of the conjugate acid means stability of the conjugate acid. So by this, all the four all the four effects, by considering all the four effects, the more basic will be the secondary, then primary, then tertiary, and that will justified by this pkv value. So ये क्वेश्चन एक बहुत कॉन्सेप्चुअल था. जो क्वेश्चन पूछा गया उसमें से वो उतना नहीं था, बिकॉज यू ऑल नो एनिलीन इज लेस बेसिक एंड द पीके वैल्यू इज 9.13. अगर किसी भी क्वेश्चन में नेक्स्ट सीएसए नेट गेट बार्क आईआईटी एग्जाम और एनी अदर एमएससी एंट्रेंस एग्जामिनेशन में ये तीनों लेकर कोई क्वेश्चन पूछ लेता है, पीके वैल्यू, पीके वैल्यू or basicity, then by this, by considering all this effect, we have to answer accordingly. For polar protic solvent, there is chance of hydrogen bond form. This is more basic. Then this, then at last tertiary. If gas phase or a solvent, there is no chance of hydrogen bond formation, no chance of protonation of that amine, then also same order: more basic, tertiary, secondary, then primary. Because in that case, we have to consider only the electron donating power of the R group. So I hope ये वाला क्वेश्चन को आप लोग समझा, जो इसका पीछे जो रीजन था कुछ. सो आई थिंक रिगार्डिंग दिस क्वेश्चन, अगर किसी भी एग्जाम में पूछते हैं नेक्स्ट अपकमिंग किसी भी एग्जाम में, तो आप लोग सही आंसर करेंगे रिगार्डिंग दिस थ्री एमिन. बट we have to consider the which solvent they are using: polar protic solvent, or there is no solvent means water, methanol. If they use polar protic solvent, then there is chance of formation of hydrogen bond. So we have to consider this case most basic. Then if there is no at all solvent, gas phase, or there is no polar protic solvent, there is no chance of hydrogen bond formation, then normal case, more basic, then this. तो ये क्वेश्चन हम लोगों ने पूरा डिस्कस कर लिया, और पूरा डिस्कस करना था ये वाला क्वेश्चन. सो लेट्स सी. सो ये क्वेश्चन पूछा गया था जो न्यूट्रॉन एब्जॉर्बर और कैप्चर, पिछले मीन्स बार्क फर्स्ट पेज एग्जाम में पूछा गया था. टू स्लो डाउन द स्पीड ऑफ न्यूट्रॉन, which we can use that answer was heavy water, that is G2O ऑप्शन में था. बट सेकंड फेज में पूछा गया था न्यूट्रॉन एब्जॉर्बर और न्यूट्रॉन कैप्चर. हम लोग कौन न्यूट्रॉन कैप्चर और एब्जॉर्बर मीन्स स्लो डाउन मीन्स जस्ट slow down the reactions, but capture or absorber means it capture neutron to stop the whole reactions, but it slow down the speed of neutron. If we pass through heavy water, then the speed of the neutron becomes slow. And for capture or absorber, to stop the reactions, we can use this mass element, xenon, cadmium, hafnium, gadolinium, samarium, molybdenum, europium. So I think question में cadmium था. So as a neutron absorber or capture, we can use this kind of element, and for slow down the speed of neutron, we can use heavy water. So इतना ही क्वेश्चन डिस्कस करना था इसके बारे में. आई थिंक आप लोगों को कुछ सीखने को मिला regarding this that amine part. Amine part means basicity of amine, and also जो लिक्विड जंक्शन पोटेंशियल रिलेटेड जो क्वेश्चन था, लिक्विड जंक्शन पोटेंशियल रिलेटेड जो क्वेश्चन था उसके बारे में कुछ सीखने को मिला. हुइस केस लिक्विड जंक्शन पोटेंशियल मैक्सिमम होगा, हुइस केस लोएस्ट होगा, एंड इन हुइस केस इट विल बी जीरो, एंड in liquid junction potential why we use the KCl. Question पूछ सकते हैं, why you use KCl, because the mobilities of K and K plus and CL are quite similar. So and that organic questions के बारे में कुछ एक्स्ट्रा हम लोगों ने डिस्कस कर लिया. So thank you guys, uh, thank you for watching, and thank you for commenting in comment box, and thank you for sharing. Again, I want to thanks Akila and Amit Kumar. So उन लोगों ने बहुत सारा क्वेश्चन शेयर किया कमेंट बॉक्स में. So I will try to make another video by uh, picking those questions जो अभी तक बचा है. So that's all for today. Thank you. Thank you for watching. Thank you for your support. So stay safe, stay healthy. Bye.